Hello everybody, it's another one of Mr. Paul's quick videos. I'm using a new camera, so I don't actually know how good the sound quality is going to be on this, so let me know. Okay, first thing, so we've been going over a couple of things today. The first one is parallel lines. Remember, parallel lines are any lines that have the same distance between them. So a parallel line is defined by two lines that anywhere you measure between them, they have the exact same measurement. Okay. The other thing we looked at was something called the perpendicular line. Perpendicular lines are the exact opposite. So they are going to meet at a 90-degree angle. Remember, this little square means that it's at a 90-degree angle, just like the angles in a square. Next one, perpendicular bisector. So the perpendicular bisector, if we have a line segment like this, okay, and we find the exact middle of that line, so this one is 6, that's impressive. We're going to put this at 3. Now I need to take my compass. It's not my compass, this is called a protractor, and I don't know if you can see, I'll bring it up. Okay, do you see where that little hash mark is? Right there in the middle? That's where I'm going to line that up with, let me zoom in on this one. I'm going to line that up with the line and where that hash mark is. I'm going to mark where the 90 is, because a 90-degree angle is at 90. I line up my two lines and I draw it right through, just like that. And the other thing to keep in mind is that whenever we are dealing with, come on, here we go. Whenever we're dealing with things that are the same length, we're going to use these little hash marks. I have one on each side, which shows me that these two sides are equal. And for the grade 8 and 9s, we are going to also do an angle bisector. So the first thing we do is we're going to draw an angle. Let's actually do an angle, line up my hash mark at, oh, let's do 60, make it easy. So right here is a 60-degree angle. If I was to bisect that, I'm going to take half of 60, which is 30. So I'll make a little dot by where the 30 is. And I connect that to the bottom. And there is my angle bisector. So that's going to be 30 and 30. Okay, so those are the four main types of lines you're going to need to put into your project today. The other thing that we talked about was the 6 types of triangles. So scalene triangle, this is my favorite because they're the easiest to draw. So a scalene triangle, we're not worried about the angles. This top part is only based on the length of the sides. So a scalene triangle is a triangle where all 3 sides are a completely different length. Remember, the hash marks that we use there help us to indicate the side length. Isosceles triangle. Isosceles is an interesting one. So this is one that has 2 sides that are the same and 1 side that is different. So here again, we can put the hash mark, showing that those 2 sides are the same, and a double hash mark to show it's different, just like Sesame Street. One of these things is not like the other. I know, I'll stop singing. Now, an equilateral triangle is a unique one, because it's going to have all sides the same. And interestingly enough, to have an equilateral triangle, all the angles are going to equal 60 degrees. Now the next section, this is about angles. So this one here, I'm going to run out of room. Let's go up this way. Angles. Awesome. So a right degree triangle. Again, if we use our compass, we're going to draw a line. And I'm going to make a 90-degree angle. So I line the hash mark up right at the corner, put a dot at the 90. I'm going to draw it straight down. Boom. Whenever I have a 90-degree angle, make sure you document it with the square. And now all I have to do is connect the dots. So this one here, if we measured it, let's just take a quick look. So this side is 4.5, this side is 5, this side is 7. So I've actually drawn a scalene right triangle because this side is different from this side, is different from that side. You can have an isosceles right triangle. The one thing you can't have is an equilateral right triangle. The reason being is that all of the angles of those need to be 60 degrees. Acute triangle. Now, if I was to draw a line and to draw an angle, this angle here is less than 90 degrees. If you're not sure, you can always put your protractor on and check. So here's 90. This one's way over here at 40. Okay, we're going to talk about how to read those next day. And I'm going to draw this angle up here. So no matter which way I check it, every one of these angles is less than 90 degrees. That is what makes an acute triangle. You can also remember they're kind of cute. Now the last one here is an obtuse triangle. So I'm going to draw my line. Now remember, 90 degrees is straight up. Okay, so that's my 90 degrees. If I'm going to have an obtuse triangle, I need one angle that is bigger than 90 degrees. I can even tell you what that one is. Line it up. That's 140 degrees there. 140 degrees. Okay, so that triangle is now, I know, is going to be an obtuse triangle if I connect the two edges. Interestingly enough, if you don't connect, what you have is an obtuse angle. So anytime we have two lines that meet, this is just called an angle. The triangles are when we connect those two sides. So those are the main things that we're going to be doing on our project.